Hello. Topic of the lecture is Introduction to Phasor Array Antennas. Array means always set of dipoles. Now, phased array is a directive antenna made up of individual radiating antennas which generate a radiation pattern whose shape and direction is determined by the relative phase difference between each element. By properly varying the relative phase of the elements, we can steer the direction of the radiation pattern. It's like the major lobe may be in the front side or maybe on the back side, maybe on the side firing. Like this, we can design the antenna radiation lobe by properly changing the phase of the current in each dipole. So the radiating elements might be dipoles, open-ended waveguides, slots, and slots in waveguide cut, or any other type of antennas. Now, it has been considered in those radar applications where it is necessary to shift the beam rapidly from one position in space to another position, where it is required to obtain information about many targets at a flexible, rapid data rate. To rotate the antenna physically, it is not possible. So, what we are doing, we are using the phased arrays, and by alternatively by changing the phase of the current that is passing through, we can change the radiation lobe from one direction to the other direction at a higher rate. When this capability of changing the radiation pattern at higher rate enables you to have vision in two directions parallelly. So it is very important. It's a very beautiful feature. Initially, it is used like in World War II with phased arrays. Now, the major advance in the phased arrays technology was made in the year of early 1950s by replacing the mechanically actuated phase shifters. Understood? Now, there are two common geometrical forms of arrays used in radar are linear array and the planar array. Linear array is the array consists of elements arranged in a straight line in one dimension. That is linear array. Planar array is two-dimensional configuration of elements arranged to lie in a plane. It's two-dimensional is called as planar array. One-dimensional is called as linear array. The two-dimensional planar array is the most commonly used in radar applications, since it is fundamentally the most versatile of all radar antennas. Very versatile and accurate, quick responding antennas is this antenna. A rectangular aperture can be produced by fan-shaped beam. A square or circular aperture produces a pencil beam. So by changing the aperture of the antenna, we can change the shape of the beam also. The array in which relative phase shift between the elements is controlled by the electronic device is called the electronically scanned array. If an electronic steering circuit is there, which will alter the relative phase between the elements to have new lobes, is called as electronically scanned array. In an electronically scanned array, the antenna elements, the transmitter and the receivers are arranged in a proper phased manner. Example is given here. Consider a linear array of n dipoles separated by d and having a incoming signal with an inclination angle of theta, as shown in this figure, carrying energies E1, E2 and E9. Now, these elements all the elements are considered as isotropic elements are not realizable in practical. They are a useful concept of array theory, especially for computational purpose. All the elements in this previous figure are receiving antennas, but because of the reciprocity principle, the results obtained are applied equally well to a transmitting antenna also. The outputs of the elements summarized by the lines in EA, E1, E2, E3 like EA. The element 1 will be taken as the reference signal with a phase shift of 0. Now a progressive phase shift is introduced in the preceding dipoles so that it will produce a signal like EA is equal to sin omega t plus sin omega t plus psi plus 2 psi plus 3 psi, like that it will continue. Now where omega is the angular frequency of the signal, and it can be written as EA is equal to sin omega t plus n minus 1 with a limit to psi. When it is 2, it is sin psi by 2. When it is psi, it is sin n psi by 2. These antennas will have a nice will have an energy out as sin n pi d by lambda sin theta divided by sin pi d by lambda sin theta. Now the factor is a sine wave of frequency omega with a phase shift of n minus 1 into psi by 2. The second term represents the amplitude factor of the form sin n psi by 2 by sin psi by 2. Now this equation is the field intensity pattern of magnitude of this equation is EA of 0. The gain of this antenna is denoted by G of theta, which is GE of 0, GE of theta into GA of theta. That GA of theta is the gain is finally can be written as GA of theta E plus theta A is equal to G1 of theta E into G2 of theta A. This is a two-dimensional radiation pattern of phased arrays. I hope you understood. Thank you.